Hello students, welcome to Learner's Planet Theory Session 5 of Periodic Classification of Elements. So students, till now we have discussed the modern periodic table in details about the elements in the groups, and we also started discussing about the valence shell electrons and the valency. Now in this session we will take up the atomic radius and its trend along the period. What happens to the atomic radius, whether it increases or it decreases along the period. We'll also talk about this metallic character of the elements. So let's start with the atomic radius. Now what it is, atomic radius or atomic size? So atomic size, what is it? The term atomic size refers to the radius of an atom. Now students, why we are calling it as radius? Because atom is spherical, or it is circular. It is a circle. It is assumed to be like that, and it is like that. We talk of its radius. Now what is an atomic radius? It is the distance of outermost shell of an atom from the center of its nucleus. Say, if I have drawn this atom, now I have got the nucleus at the center. So this is what? This is your nucleus. This is what? This is the nucleus. And this is the valence shell. I hope you can get what is valence shell now. Valence shell is the outermost shell of an atom. So this is what? This is valence shell. So what is atomic radius? It is the average distance between the center of the nucleus and the valence shell. Now this tells you the radius of atom. This is the radius. Now is it possible exactly, what we say that the electrons keep on moving around. So they are in motion. Can we exactly get the location of the valence shell? No. So that's why what is done is that the atomic radius is measured in its molecule. Like in a covalent compound, it would be a covalent radius. That is the distance between the two atoms. Say these are the two atoms which are bonded, and the distance between their centers will be what? Covalent radii. This you don't have to do. I'm just telling you an example. So this would be covalent radii. Likewise, the distance between the nucleus of the two atoms bonded by ionic bond will be what? Ionic radii. The distance between the two atoms bonded by the van der Waals forces of attraction would be what? Van der Waals radii. Now what is the unit for measuring radius? We know that atom is a very small entity. So how can we measure? The radius is measured in angstrom units. Angstrom units, where 1 angstrom is equal to 10 to the power minus 10 meters. Remember this, that 1 angstrom is equal to 10 to the power minus 10 meters. This conversion you'll be requiring every time you're doing is the structure of atom or about the atom. Now the atomic radius decreases as one moves from left to right in a period. That is, the atomic radius is decreasing. Let's see how it goes. Say if I take the elements of the second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. What is happening to the radius? It is atomic radius in angstrom. So it is 1.06, 0.88, 0.77, 0.70, 0.66, 0.64 and 1.12. So what has happened here? If you see this, the atomic radius, I'll write it again because it's creating confusion to me also. So I'll write it like this. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So your lithium here is 1.52, beryllium is 1.06, boron is how much, students? Boron is 0.88, So boron is 0.88, carbon is 0.77, nitrogen is 0.70, oxygen is how much? 0.66, fluorine is 0.64, and neon, it is what? It is 1.12. Now if you see the trend along the period, what is happening here? So along the period, what is happening to the radius? The radius is decreasing. But what about the radius of the noble gas? Like neon. What has happened to this? It has increased. So what is happening along the period, students? It is that the radius is decreasing, but it increases at the noble gas. Likewise, you check out for this third period. What are the elements of the third period? They are sodium, then magnesium, then aluminium, then is what? Aluminium, then comes your silicon, then phosphorus, then sulfur, then chlorine, and then argon. So what is happening to the atomic radius? It is going on decreasing, and it increases at the last. Again, the noble gases, it increases. So let's see why this decrease or increase is there. Now what can we conclude from the table? We can conclude that the atomic radii gradually decreases from left to right in a given period. That is happening here. Left to right. What is happening? The atomic radius is decreasing. Left to right. The atomic radius is decreasing. The atomic radii of noble gases, such as neon and argon, increase more as compared to its predecessor. So what is happening? It is increasing. Now what is happening here? The rest of the radius are decreasing, but the noble gas is increasing. So it is increasing, we can say, as compared to the predecessor is not required here. So what is happening? The atomic radius of the noble gas is increasing. Now let's see why this happens. Reason for the decrease of atomic radii along the period from left to right. From left to right in the period, there is consecutive addition of a proton in the nucleus and an electron in the valence shell of the element. The electron is always added to the valence shell in a given period. See, we'll make circles. We'll write the elements above it. Okay. So, this is the first period. This is bigger circle. The more bigger circle. The more bigger circle. No, along the period what we can do is we can draw the circle of same size because the shells are not increasing. So what is happening that we have got the 1, this is 3, this is 4, this is 5. Now what is happening here? So let's see. So this is, if I am taking it as lithium and I am taking it as beryllium, then I am taking it as boron, then I can take it as carbon. And then I can take it as nitrogen. So what is happening? These all belong to which period? These all belong to second period. So there would be nucleus and there would be the valence shells. So what is happening in these is that every time your this electron is added to the same valence shell. Say that is, this is your lithium. In this, there is a nucleus, there is one more shell. There is one more shell around here. So what is happening? In this, there was one electron in the valence shell. Now, in this case, it became how many electrons in the valence shell? There came 2 electrons in the valence shell. In case of boron, how many electrons came in the valence shell? In boron, how many electrons came in the valence shell? They became 3. 1, 2, and 3. In case of carbon, how many electrons came in the valence shell? They became 4. Now, my purpose of telling you this is that what is happening in the nucleus, the charge is increasing. In this valence shell, there are 5. Now, in the nucleus, the number of protons are increasing. Here, how many protons were there? There were 3 protons. Here, how many protons came? 4, 5, 6, 7. But did the number of shells increase? Say, if I am drawing this circle and every time I am increasing the number of shells, so what will happen? The distance from the nucleus will increase. But in this case, what is happening? The distance remains the same. That is, the distance or the electrons are added to the valence shell only. Okay. Now in this case, what is happening? In the nucleus, the charge is increasing. So it has got more positive charge. What it will do? It will try to attract the valence shell electrons. So it is trying to give more attraction force to the valence shell electrons. So when it is exerting more attractive force on the valence shell electron, what will happen? The radius will go on decreasing. So in a nutshell, I can say that the number of protons in the nucleus is increasing. The electrons are added to the valence shell. No more shell is added. So what happens that the force of attraction which nucleus exerts on the valence shell increases. That is why what happens that the radius decreases. Moving back to our file, it is the addition of proton in the nucleus increases the positive charge, which exerts attractive force on the extranuclear electrons in the valence shell. Extranuclear means which is external to the nucleus. Now let's take up the reasons such as what happens. The atomic radius decreases from left to right in the period. Now this is the thing which you have to remember. I have written it in bold, but still I would like to tell you because it can be asked in your objective type question. Now, but what we saw was that the atomic radius of the noble gas increases. Now what is the reason for it? See, I'll just draw a rough diagram here. Say, in the valence shell of the noble gas, how many electrons are there? A. Now what they do, they repel each other. They repel from each other because what happens that they become congested. The electrons become very close to each other. Just assume a class in which there are say 4 students. So what will happen? They'll sit far apart from each other. Or they can sit in say 2 desks also. But if in that class there are more than 30 students, what will happen? There will be congestion. There will be fight among the students. Give me this place. I want to sit here. You are taking more space. You are keeping your bag there. What will happen? There will be fight between the students or argument between the students. There won't be that peace in the class. Now this is what the thing which is happening here also. In this valence shell, there are 8 electrons and the size of the shell is not that big. So what they do? They repel each other. Just like kids, they fight with each other. Why are you keeping your bag in my desk? Why are you keeping your pencil here? Why are you doing that? If the class becomes congested, this happens there. Same as the case with this. That is, the shell becomes so crowded that these electrons start repelling each other. Now due to this repulsion and its structural stability, the radius increases. So the size of the atom of inert gas is bigger than that of the preceding halogen atom. Why? The greater size of the inert gas atom in a period is due to the structural stability of its outermost shell consisting of an octet of electrons, or you can say it is due to the structural stability also, and it is due to the repulsion between the electrons also. So this is the reason for increase in the size of the atomic radius of the noble gas. Let's take up its next property, that is the metallic and non-metallic character of the elements. Now before discussing it, I would first like to just do the recap of the properties of metals and non-metals. So first of all, what is the basic property of metal? It is like, I am talking about chemical properties. I am not talking about the physical properties, that it has luster, it has shine, about its density, about its melting point. I would straight away come to its chemical property, due to which metal has those physical properties. So, metals, the basic property is that they form electropositive, or they form positive ions. The basic property of metal. If I am taking magnesium here, which is a metal, what it is forming? It is forming Mg2 plus. Or if I am taking aluminium, it is forming Al3 plus. If I am taking lead, it is forming what? Pb2 plus or Pb4 plus. So, your metals, they are forming positive ions, whereas non-metals, they are forming negative ions. Like oxygen, it is forming what type of ion, students? Your oxygen is forming O2 minus. Chlorine is forming Cl minus. So, your this thing. So, non-metals form what type of ions? Negative ions. This is the basic difference, the very basic chemical difference between metals and non-metals. And on the basis of which we will grade them along the period. Now, on moving from left to right in a given period, the metallic character of elements gradually decrease. How? The metals present on the left hand, the metals are present on the left hand side of the period, that is, atoms of metals always lose electrons and hence are electropositive. And non-metals are present on the right side of the period, that is, non-metals either gain or share electrons and hence are electronegative. Now let's see, why is it so? What I told you was that the number of electrons are added to the valence shell and the force of attraction, what I told you was that the force of attraction between nucleus and valence shell increases when we move from left to right in a period. Now what is happening? See, if I talk of sodium, it has got a big atom. Now in this case it has got a single electron and this is your nucleus. And if I talk of fluorine or if I talk of chlorine, so chlorine is what? Chlorine is a small atom. Now in this case, what else? How many electrons are there? There are 7 electrons in a nucleus. Now what happens that the sodium can easily lose its electron. Why? Because the force of attraction between nucleus and valence shell is less. Whereas if I talk of chlorine, it cannot lose even a single electron easily. Why? Because the force of attraction is more. So if I write like this, so this is your chlorine. So force of attraction, where students, between the nucleus and the valence shell, in case of sodium is less as compared to chlorine. So what is a metal? Which one is the metal? Sodium. Because it can easily form Na plus ions, whereas Chlorine is what? It is a non-metal because it is forming minus ions. Let's see how this happens. Now students, there are some elements in between metals and non-metals, and they have properties between those of metals and non-metals. These elements are called as metalloids. That is, they have got both the properties, the metallic as well as the non-metallic. So metalloids, they have some characteristic property of metals, but they lack others. For example, silicon. It looks like a metal, but it is brittle. Are metals brittle? No. But silicon is brittle. Even your silicon, these metals are very, very good conductors of electricity. But non-metals, they do not conduct electricity. But your silicon is used as a semiconductor. So under certain conditions, it conducts electricity. So it is a semiconductor. Now oxides of metals are, students, they are basic in nature, whereas the oxides of non-metals, they are acidic in nature. But oxides of semi-metals, these are usually amphoteric. Now let's take up some metals, that is elements of second period. That is, lithium is a metal, beryllium is a metal, boron is a metalloid, carbon is a non-metal, nitrogen non-metal, oxygen non-metal, fluorine non-metal, but neon is a noble gas. Now what happens to the electronegative and electropositive characters? Across the period, what is happening to the electropositive character? That is the tendency to lose electron. What is electropositive character? I will write it electropositivity. So it is the tendency to lose electron. Now what I told you was that the force of attraction between nucleus and the valence shell increases along the period. Just mind it, increases. So if the force of attraction between nucleus and the valence electrons is increasing, can it easily lose electrons? No. The electropositive character decreases from left to right and electronegative character decreases from right to left. Now say the sodium is a metal, magnesium metal, aluminum is again a metal, but silicon is a metalloid, phosphorus non-metal, sulfur non-metal, chlorine non-metal, and argon is a noble gas. Again, the electropositive character, just I'll do it so that you can compare. Now the electropositive character, what happens? It is decreasing. Decreasing of what it is decreasing? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So the tendency to lose electron is decreasing. That is why sulfur forms S2 minus ions and chlorine forms Cl minus ions. And students, electronegativity. What is electronegativity? The tendency to gain electrons. So what is happening to electronegativity? It is decreasing from right to left. Can sodium form Na minus ion? No. Can magnesium form Na minus? No. So it is decreasing. Now from the table it is very clear that as one moves from left to right in a periodic table, what happens? The electropositive character of the elements gradually decreases. That is the tendency to lose electrons. Electropositive character means tendency to lose electron and form positive ion. I'll again write it here because it is very, very important. Electropositivity. It is what? This is tendency to gain electrons. lose electrons. It should be tendency to lose electrons. And form what type of ions? And form positive ions. And what is electronegativity, students? It is tendency to gain electrons. And form what type of ions? Negative ions. So, what happens to the electronegativity along the period? It increases from left to right. And what happens to electropositivity along the period? It decreases from left to right. So students, we have discussed about the characteristics like metallic and non-metallic, and also about the atomic radius. Now in the next session I will be telling you about the reactivity of elements, their along the period, and also the anomalous behavior of the elements of second period. So we'll be meeting in our next session. So thank you very much for listening patiently.